Hello, in this video, we'll walk through how to solve a polynomial equation from a math exam question. Our objective is to find the value of x. The equation we're tackling is x squared minus x cubed equals 30. Solving cubic equations can be tricky. They often involve higher-level techniques you might learn later. However, exam questions are usually designed to have a simpler, more intuitive solution if you look for it. Our goal here is to solve this without any advanced methods. So, let's look for a clever way to do it. Our first step is to rearrange the equation. When dealing with polynomial equations, it's almost always a good idea to set one side of the equation to 0. So we have x squared minus x cubed equals 36. Let's move all the terms to the left-hand side. We can subtract 36 from both sides to get x squared minus x cubed minus 36 equals 0. It's often easier to work with a positive leading coefficient. In this case, the highest power of x cubed has a coefficient of -1. Let's multiply the entire equation by -1 to make it positive. Multiplying by -1 changes the sign of every term. So we get x cubed minus x squared plus 36 equals 0. This is the standard form of a cubic equation, and we are now looking for the roots of this polynomial. Now we're faced with a cubic equation. X cubed minus x squared plus 36 equals 0. Solving this directly is not straightforward. Since this is an exam question, we should look for an integer solution first. We can do this using a method called the rational root theorem. This theorem tells us that any rational solutions must be a fraction where the numerator is a factor of the constant term and the denominator is a factor of the leading coefficient. In our equation, the constant term is 36, and the leading coefficient is 1. This means any integer solutions must be a factor of 36. Let's list the factors of 36. They are plus or minus 1, 2, 3, 4, 6, 9, 12, 18, and 36. This gives us a list of possible integer roots. Now, we can test these values in our equation to see if any of them make the equation true. Let's systematically test the factors of 36 to find a root. Let's start with x equals 1. Plugging 1 into the equation, we get 1 cubed minus 1 squared plus 36, which is 1 minus 1 plus 36, or 36. This is not 0, so x equals 1 is not a root. Let's try x equals 2. Plugging in 2, we get 2 cubed minus 2 squared plus 36, which is 8 minus 4 plus 36. That equals 40, which is also not 0. So x equals 2 is not the answer. How about x equals 3? Plugging in 3, we get 3 cubed minus 3 squared plus 36, which is 27 minus 9 plus 36. This simplifies to 18 plus 36, which is 54. Still not 0. Let's keep trying. Notice that the values are increasing. This suggests we should try negative numbers. Let's try x equals -1. Plugging it in, we get -1 cubed minus -1 squared plus 36. This is -1 minus 1 plus 36. This simplifies to -2 plus 36, which is 34, not a root. Let's try x equals -2. We have -2 cubed minus -2 squared plus 36. That's -8 minus 4 plus 36. This is -12 plus 36, which equals 24. We're getting closer. What about x equals -3? This gives us -3 cubed minus -3 squared plus 36. This is -27 minus 9 plus 36. -27 minus 9 is -36, and -36 plus 36 is 0. We found it. X equals -3 is a root of the equation. So we've established that x equals -3 is a solution. This means that a factor of our polynomial must be x minus 3, which is x plus 3. We can now use polynomial division to divide our original cubic polynomial by this factor. This will give us a quadratic equation, which is much easier to solve. Let's perform the polynomial division. We are dividing x cubed minus x squared plus 36 by x plus 3. To make the long division clearer, we can write the polynomial as x cubed minus x squared plus 0x plus 36, so all the terms are present. First, we ask, what times x gives us x cubed? That would be x squared. We write x squared on top. Then we multiply x squared by x plus 3, which gives us x cubed plus 3x squared. We subtract this from the polynomial. The x cubed terms cancel, and we're left with negative 4x squared. We bring down the ux. Now we ask, what times x gives us negative 4x squared? That's negative 4x. We multiply negative 4x by x plus 3 to get negative 4x squared minus 12. Subtracting this gives us 12x. We bring down the 36. Finally, we ask, what times x gives us 12x? The answer is 12. We multiply 12 by x plus 3 to get 12x plus 36. Subtracting this from 12 vs x plus 36 leaves us with 0. This confirms our division is correct. So we have factored our cubic equation into x plus 3 times the quantity x squared minus 4x plus 12 equals 0. We've simplified the problem to a point where we can use a standard formula. We're almost there. Our equation is now factored into x plus 3 times the quadratic x squared minus 4x plus 12 equals 0. For this product to be 0, one of the factors must be 0. This gives us two separate equations to solve. First, we set the linear factor to 0. X plus 3 equals 0. Subtracting 3 from both sides gives us our first solution. X equals negative 3. We already found this root by testing, so it's a good confirmation. Second, we set the quadratic factor to 0. We need to solve x squared minus 4x plus 12 equals 0. We can use the quadratic formula for this. The quadratic formula is x equals negative b, plus or minus the square root of b squared minus 4ac, all divided by 2a. In our equation, a is 1, b is negative 4, and c is 12. Plugging these values into the formula, we get x equals negative 4, plus or minus the square root of negative 4 squared minus 4 times 1 times 12, all divided by 2 times 1. Simplifying, we have 4 plus or minus the square root of 16 minus 48, divided by 2. That's 4 plus or minus the square root of negative 32, divided by 2. Here we see a square root of a negative number. This tells us the other two solutions are not real, but complex numbers. The question just asked to solve for x, implying we should provide all possible solutions. The square root of negative 32 can be written as the square root of 16 times negative 2, or 4 times the square root of negative 2. Using the definition of the imaginary unit, I, we can write the square root of negative 2 as I times the square root of 2. So we have 4 plus or minus 4i times the square root of 2 divided by 2. Dividing by 2, we get our two complex solutions. X equals 2 plus 2i times the square root of 2, and x equals 2 minus 2i times the square root of 2. These two complex solutions, along with our real solution of x equals negative 3, are the three roots of the cubic equation. So our complete set of solutions is x equals negative 3 and x equals 2 plus or minus 2i times the square root of 2. Let's quickly recap what we've accomplished. Our objective was to solve the exam question x squared minus x cubed equals 36. We started by rearranging the equation into a standard cubic form. This gave us x cubed minus x squared plus 36 equals 0. We then used the rational root theorem to test for a simple integer solution, and we found that x equals negative 3 was a root. Finding this root allowed us to use polynomial division to factor the cubic equation. The result was a linear factor, x plus 3, and a quadratic factor, x squared minus 4x plus 12. From the linear factor, we got our first answer, x equals negative 3. Using the quadratic formula on the second factor gave us two complex answers. X equals 2 plus 2i times the square root of 2, and x equals 2 minus 2i times the square root of 2. This problem is a great example of how you can combine different algebraic techniques, like the rational root theorem, polynomial division, and the quadratic formula, to solve a challenging equation. Thank you for watching, and I hope this walkthrough was helpful. If you enjoyed this, feel free to like the video and subscribe for more math solutions.